Welcome back again to Clever Bintex and Science TV. Today we are going to look at geometric distribution of a random variable. This is very simple and very easy to follow. Assume that x represents the number of trials until our first success. How can we formulate this formula of getting geometrical distribution? So we are going to say the probability that x is equal to x given this particular function qxp, whereby x is ranging between 0, 1, 2, until further notice. For us to find the probability of the success, because we said let x represent the number of trials until our first success, you'll be saying that x, if it is its probability, therefore the probability of x is said to be p into 1 minus p raised to x minus 1. So for us to find the moment generating function, at a particular point t, so the MGF of the value t, xt, is being given as the expectation of the exponential function raised to tx. And this particular expectation, you know that it is the same as writing the summation of exponential tx multiplied by the probability of x, So how are we gonna consult this one? So we'll be saying that, remember that our values are ranging between x is equal to 1 until x is infinity. So when we say summation when x is equal to 1 up to x is equal to infinity of this exponential tx, then we multiply by what? P into 1 minus p raised to x minus 1, p into 1 minus e tx times p into 1 minus p raised to x minus 1. So we want to factorize this p. Let us remove p outside. So this is our equation going to be p summation of x from 1 up to infinity, then exponential tx, you multiply by 1 minus p into raised to x minus 1. This one you can write it as p, then a summation of when x is 1 up to infinity of 1 minus p x minus 1, then multiply by exponential tx, then multiply by exponential tx. So suppose that at this particular point we have k. I want to introduce another constant k. When k is 0 at its lower limit, let me say at its lower limit, when k is equal to 0, it simply means that k will be x minus 1. So therefore, x is the same as writing k plus 1. So when we rewrite this equation here, this one, so we're gonna say that p summation, when now we are going to use k, but when k is what? 0. So from k is equal to 0 up to k is infinity, will be exponential raised to tk into 1 minus p k minus 1 minus pk minus 1. But remember that our value of x was k plus 1. So instead of using this k, we are going to use value of x. So I was just writing this one when k was 0, but remember that your x was 1. So when the value of x was 1, you'll be saying that the probability summation of k is equal to 0 and k is infinity, that will be exponential t into k plus 1, because our x was 1 and our exponential was raised to tx, so it is k plus 1 when k is 0. Then I multiply by 1 minus p into, because it was 1 minus p x minus 1, but our x is k plus 1, so it will be k, when you consider here, it will be k plus 1 minus 1. So plus 1 minus 1 is just is just k. So this place will be 1 minus p raised to k. 1 minus p raised to k. So I want to remove this bracket here so that I not have something that is very crucial. So I'll be saying p, then summation of this is k is equal to 0 up to k is infinity, at its infinity. Let me factorize this one. So exponential, this one will be exponential. I want to open the bracket, exponential tk multiplied by exponential raised to t, multiplied by exponential raised to t, because this is exponential tk plus t. Then I'll multiply it again by 1 minus p raised to k. But exponential t is our constant. So exponential t is our constant. When we factorize it, we'll remove it outside. So this one gonna be p exponential t summation when k is 0 up to infinity, then we multiply by what? Exponential tk times 1 minus p into k. 1 minus p into k. So as you look, exponential raised to tk and 1 minus p raised to k, k here is a common factor. So when multiplying it, we can rationalize it by saying p exponential t summation when k is 0 up to k is infinity. This one gonna give us exponential. This one gonna give us let me start with this one. 1 minus p multiplied by exponential raised to what? I want to factorize out this k, exponential raised to t, but everything is raised to k. Everything is raised to k. So it is 1 minus p exponential raised to t, but everything is raised to k. Hold on this one. So you'll be saying that we have got this function p exponential raised to t, then summation of 1 minus p into multiplied by exponential t, then everything here is raised to k. Everything here is raised to k. But my k is ranging between 0 to infinity. My k is ranging between 0 to infinity. Now considering this function here, whereby your k is ranging from 0 to infinity, I have got this function 1 minus p, then I multiply by e raised to t, this one raised to k. But my k is ranging from 0 to infinity. Using geometrical function, we'll be saying that when we want to expand this one is the same as writing 1 plus 1 minus p exponential t plus 1 minus p exponential raised to t squared plus 1 minus p exponential t raised to q plus that. So when you look at this one is now called a geometrical series. This is a geometrical series. And because we have a geometrical series, so our A is equal to 1. Our A is equal to 1 and our R is equal to. When we have our A is 1, we're going to have our R at the same time. So actually, we'll be saying that when our R is 1 minus P exponential raised to T, this is our R, 1 minus P exponential raised to T. Therefore, we're going to say that for us to find R, we usually say that R is equal to A over 1 minus R. Yeah, this R simply means the common ratio. This R is the common ratio. And so we said that A is equal to 1, R is equal to 1 minus P exponential T. Then we know very well that let me rename this one, just name it even y, can say y is equal to a over 1 minus r, y is equal to a over 1 minus r. So considering our equation, p exponential raised to t, when we solve this one now, when we solve this function very well, just the same as we want to do it here, it will be this one, then we multiply by a over 1 minus r. But what was our r? Our r was 1 minus p exponential raised to t. So this one going to be p t multiplied by a over 1 minus, my r was 1 minus p exponential t. But what was my a in this series? My a was 1. In this series here, my a is equal to 1. So it will be p exponential t multiplied by 1 over 1 minus p exponential t. So guys, when you see here, I said that the probability, we can say that the probability until we find the first success, we named it to be p. And again, the probability that we've tried so many failures will be p minus 1, whereby we can say it is not p minus 1, but 1 minus p, which we can say that it is q. So the probability of the number of failures that we have is 1 minus p, which is equal to q. So we can substitute this q into our equation. So this one gonna be p, when we multiply this one, so it will be pt over 1 minus p exponential t. So we can substitute it by saying it is p exponential t over 1 minus, remember that 1 minus p, we said that it is q. So it is 1 minus p, that will be q exponential raised to t. So this one marks the end of our geometric distribution of a random variable, and this is the answer.